All right, guys. Hopefully, y'all enjoyed the longer than a week off.
I did. I enjoyed it much. I went camping. I got sick. I worked out. I worked every day. It was not great.
Now, what we're doing today is continuing on with our logarithms. Logarithms and exponentials is what we were covering before the break. And what we're looking at today are three properties of logarithms. We have the product property, quotient, and power property. Now, the product property says if we have two or more things being multiplied together inside the logarithm, we can rewrite it as a sum of those products. So log base b of m times n is equal to log base b of m plus log base b of n. We can expand it out. And in some ways, this will make it easier with solving, simplifying. We can take it from 1 to 2. And a lot of times when we're solving, we want to take two logarithms and make them into a single one. We want to simplify it down. But it also works out that if we have two logarithms with the same base being added together, we can rewrite it as a single log with what's inside being multiplied. Our quotient, if we have two things being divided inside the log, we can rewrite it as two logarithms being subtracted. And our power property says that if we have a number to a power, we can move that exponent out front. Now, in simple terms, what this is telling us is that we could take, say, log base 8 of 2 times x. Log base 8 of 2 times x. We have two things being multiplied together inside the log. We can rewrite it as a sum. So we have log base 8 of, well, one of our numbers being multiplied inside the log is 2, plus our other is log base 8 of x. We have two or more things being multiplied inside the log. We can rewrite it as a sum of those logs. Same thing's true with our division. We can say log base 6 of 3/7. Since I have two things being divided inside the log, we can rewrite it as subtraction. And our power property says we can take the exponent and move it out front. So if we have log base 5 of, say, 2 to the x, our power property says we can move it to the front, telling us that we have x times log base 5 of 2. Questions on these properties here? Questions on how these are working? When we expand and when we break or pull this all the way apart, the first one we want to use or apply is going to be our quotient. Applying the quotient property first is going to make these a little bit nicer to work with. The second property we'll apply to it to expand it is going to be our product. And the last one is going to be our power property. So we're going to, when we're expanding it, we'll take care of the quotient first, our division first, then our multiplication, our product, and lastly powers to expand it all the way out. And when we expand it all the way out, what we're going to get is something like this here. We're going to get it where what's inside, we have a single term, single number with no exponents. Now, the natural log and log, the properties for ln, log are the same. Ln is just the base is e. Log is either the number written or 10. So when we look at this here, the natural log of 5x to the 7 over y. Again, our first property we're going to apply is our quotient. We'll use m and n. Because the natural log of m divided by n is equal to the natural log of m minus the natural log of n. Well, m in our case is going to be what? Five, what? To the 7 minus n in our case is y. Because it's the natural log of the top minus the natural log of the bottom. Anything on the bottom of the fraction is going to have a negative out front. For it to be in the bottom of the fraction, it's going to have that negative out front. That's just a way that we know that that should end up in the bottom or came from the bottom of the fraction. Questions on this so far? So we've taken care of division. There's no fractions inside any of the logs, so we can move on to our product. The natural log of m times n is going to be the natural log of m plus the natural log of n. Well, this first one's the only one where we have a product taking place. Now we can put parentheses around this when we apply it, but since there's no sign in front, it's not going to make too much of a difference. Because what we'd have is the natural log of 5 plus what? Natural log of x to the 7th minus our natural log of y. Because the two main terms that we have in, the first one is 5 and x to the 7th. Questions on this here? And the last one is power, our exponent property. Because since we have x to a power inside the parentheses, inside our log, we can move the 7 out front, giving us 7 times ln of x. And that's fully expanded. So the fully expanded form of this is the natural log of 5 plus 7 times the natural log of x minus the natural log of y. And that's it. Now, I will say there's a lot to this and not a lot to this all at the same time. It's just keeping these properties straight and taking them one at a time. Questions on this here? Questions on any of this? Anything not make sense or not sure about? Are we good with this here? Okay. So the next one here, we want to expand ln of 3x to the 5th over y. So our quotient would be first, and we would rewrite this as ln of what? 3x to the 5th minus ln of y. Questions on this so far? So that's our only division. Now the product, our first one, The 3 and x to the 5th are being multiplied, so we can rewrite it as what? ln of 3 plus ln of x to the 5th minus ln of y. And lastly, we have to work with our power property, so we can move that 5 to the front, telling us that we have ln of 3 plus 5 ln of x minus the natural log of y. Questions on this here? Are you ready for the next one? Log base 6 of 3x to the 4th. So looking at this here, do we have a quotient? Do we have a division inside the log? No, we're not always going to have all of these here. We don't have a quotient, so we just move on to product. Product, because we do have two things being multiplied together. We have the 3 and x to the 4th. So we can rewrite this as a sum of logs. So it's going to be log base 6 of 3 plus log base 6 of x to the 4th. Now log base 3 is 6. Log base 6 of 3 is as simplified as it gets. But with our other term, we can move the 4 to the front, our power property, telling us that we can simplify it to 4 times log base 6 of x. And we know that both of those logs are positive because the numbers inside of it, the terms are inside, are on top of the fraction, they're on the top. So we're good there. Questions on this so far? You ready for the next one? Yes? Okay. Natural log of 5 over 12x. Well, unlike the last one, we do have a quotient. So this would start off as ln of 5 minus ln of 12x. ln of 5 minus ln of 12x. ln of 5 minus ln of 12x. Now ln of 5 does not have a product this time. But our ln of 12x, we do have two things being multiplied together. So we will have ln of 12 plus ln of x. Yes? This one we're going to need to put parentheses around it. Because as I stated already, if it's going to be on the bottom of the fraction, it has to have a minus out front. So that negative, which is telling us it's in the bottom of the fraction, isn't just being applied to the ln of 12, it's actually being applied to both the ln of 12 and ln of x. So one way we can do this is just leave it as this here with those parentheses. I would take this. Because the only thing we can do more than this is to apply this negative to both terms. Telling us that we have ln of 5 minus ln of 12 minus ln of x. Because since the 12 and the x are both in the bottom of the fraction, they're going to have that negative out front to signify that they are in the bottom of the fraction. Does that make sense? So this is really the only case where we have to be careful if we have more than one term in the bottom of the fraction. In front of each of those logs, we'll end up with a negative. Any questions on expanding? The only other direction we can go now is to condense. Condensing. Now when we condense, I've worked with it and did different things, and the best way I've come up with, or I think is the best way to go about this, is we're going to take it in two main steps. First is going to be powers, and then product, and then really we're going to simplify where needed. And the reason that we only have 2 and don't have 3 is with our powers, we're also going to take negatives as a part of our exponents. If there's a negative or minus out front, we're going to take it up as an exponent. Now the reason this is helpful, or this is nice, doing it this way, is mainly for problems like number 6, where we have those 2 negatives and are working with that there. Because if we're looking at this or trying to simplify this, we're really going to have to group those negatives so they're all next to each other, factor the negative out, and do a whole lot of other steps. Or we can do it like this here. Now the way this looks is we'll look at this next one here, log of 9 plus 3 log of 2 minus log of 3. First thing we're going to do is our power property. And our power property stated if we have an exponent inside, it comes out to the front. The reverse of this is if we have a number being multiplied in front of the log, it's going to go back to being an exponent. Now log of 9 didn't have an exponent, so it's just going to stay log of 9. We can take that positive 3 and move it back to the exponent, telling us that the middle one is really the same as log of 2 to the 3rd power. Now, as I said, we're also going to take the negatives. Well, really, what's the number in front of log of 3? 1. And since it has the negative, it's negative 1. So we can actually take that negative 1 and move it up to the exponent. Now for some, not all, but for some of these condensing these logarithms, doing these steps is going to make it nicer. Some it's just adding steps. But I feel on a whole, doing this is going to make it a little bit easier for us to keep track of. Now since we pulled the negative up into the exponent, what do you think the sign in front of the log is going to be? Positive. And this is why we also don't have a quotient on condensing anymore. Because our quotient said if we have two things being 2 logs of the same base being subtracted, we can rewrite it as division. Do we have subtraction anymore? No. So now we just need to look at product. If we have 2 or more logs with the same base, they all have the same base, being added together, we can rewrite it as a single log with each of their terms being multiplied. Because we're just going in reverse. We're saying that log base b of m plus log base b of n is equal to log base b of our m times n. It's what we did for expanding, but we're just going in reverse. Questions on this here? Especially with variables or any of these here, that 3 to the negative first power, we can't just leave it to the negative first. The way we fix that is we take it from the top of the fraction to the bottom, or the bottom of the fraction to the top. So 3 to the negative 1, we'd move it to the bottom to give us 3 to the first. On top we have 9 times, well, 2 to the third. We can simplify that. That is 8, because 2 times 2, 2 squared is 4, 2 cubed is 8. Nine times 8 divided by 3. We'll actually simplify to 24. Is 9 times 8 is 72. Divided by 3 is 24. So log of 24. Now it's not asking us to find log of 24. We just wanted to condense it. And any way we can simplify once we get it condensed, we'll need to simplify. Questions on condensing? We ready for the next condense? Log of 6 plus 4 log of 3 minus log of 3. Well, log of 6 doesn't have any exponents numbers in front to be put back as exponents, so it's good. Plus 4 log of 3. Well, we can move the 4 back to being an exponent. So it just gives us plus log of 3 to the 4th. And the last one, we can move that negative 1, giving us plus 3 plus log of 3 to the negative 1. Now let's say if it had said minus 2 log of 3, well, we can take that negative 2 and move it to the exponent. We just take the number and the sign with it. Questions on this here? We have 3 things, 3 logs, 3 of the same logs that are being added together. So we can rewrite it as a single log with what's inside each of them being multiplied. Now our 3 to the negative 1, we can move that 3 from the top of the fraction to the bottom to make that exponent positive. 3 to the 4th is 81. And we can simplify 6 times 81 over 3. The calculator can do it also. But it'll tell us that it's 162. Questions on this here? Log of x minus log of 9. So this is one of the cases where, especially doing this power, taking the negative is actually an additional step. I'll show it with taking the negative. Because here we don't have any powers. There's not a number in front of log of x besides 1. There's not a number in front of log of 9 besides our negative 1. Now we can take that negative 1 and put it as an exponent. Which is really just going to tell us that we have log of x plus log of 9 to the negative first. We have 2 being added, so we can say this is the same as our multiplication. And lastly, we do have to fix that negative exponent. Questions on this here? So again, if we have 2 terms, this is not necessarily the fastest way to get there. Is our quotient property said that log base b of m divided by n is equal to log base b of m minus log base b of n. That's just our quotient property. Here, especially since we have 2 terms being subtracted, well, our b in this case is 10. We're not having to write it. What's m for us here? M is, n is. Because we had 2 terms being subtracted, just applying the quotient is a little bit nicer. Where we have some of these 3 terms, these multiple terms, positive, negative, it makes it a little bit harder to just apply them or see that application. It is possible, but sometimes pulling that negative as an exponent isn't necessarily the fastest, but it does work. It does work on each of these here. Questions on these here? Let's look at number 8. Natural log of 4 plus 3 times the natural log of 3 minus the natural log of 12. Well, the natural log of 4, because again, our first step in condensing is to do our powers. So with our middle term, we can move that 3 back up into an exponent. So telling us that the middle one is the natural log of 3 to the third. Minus our natural log of 12, well, we can move that negative up into the exponent, giving us the natural log of 12 to the negative first. Any questions on how we got to this point here? Questions on this so far? Okay. Now we have 2 or more logs being added together, same logs being added together. So we can rewrite it as a single log with what's in each side of the logs being multiplied together. Now really, since everything inside this log is just straight numbers, we could use a calculator, let it do it for us. But especially with variables, or if a variable has a negative exponent, like the 12 to the negative first, we'd move it to the bottom of the fraction with whatever the exponent is. But since here the exponent's -1, 12 goes to the bottom of the fraction, and we get 12 to the first, or just 12. On top, we have 4 times, well, 3 cubed is 27. And then we're simplifying this here. 3 ends up giving us the natural log of 9. Questions on any of this here? Now, one of the main reasons that this is useful or this is handy is especially evaluating logarithms. Now, Unfortunately, well, fortunately for us, we have calculators that can actually calculate logs no matter what they are. We can be given any log with any base and we can actually find it, it'll calculate it for us. But that's not always been the case. Because it used to be that we had log tables, which was literally printouts and tables of logarithmic functions. And they would have certain ones. So we could say that we had a table of log base 2 to say 15. Or it would only do so much because we can only fit so much on a sheet of paper. But utilizing these properties helped us be able to find logs that weren't necessarily in the table. Because they wouldn't put log base 2 of 3/7. Because it wouldn't make sense, because if I did 3/7, I would have to do all of our sevens. But according to our quotient property, log base 2 of 3/7, because we have something being divided inside the log, is the same as log base 2 of 3 minus log base 2 of 7. So this is nice because as long as I have, say, log base 2 of 1 through 10, we could take care of any fraction with a denominator of 2 through 10. Because we could do 1/2, 3/5, because it does tell us in the table what those values are. Log base 2 of 3 is told to us to be 1.585, minus log base 2 of 7 is 2.807. So since we knew what log base 2 of 3 and log base 2 of 7, I could use those with these properties to actually find out what log base 2 of 3/7 is. Now at this point here, we just need to subtract these two. 2, 6. And we should get negative 1.222. 585, 2807. Negative 1.222. Questions on A? Questions on these so far? Let's look at B, log base 2 of 21. Now we need to use 3 and 7 to get to 21. 3 times 7 is 21. Because our properties, we have product, quotient, power. We're either going to be multiplying, dividing, or putting it to a power. 3 times 7 is 21. And since we have two things being multiplied together inside the log, we can rewrite this as multiple logs being added together. So we can say that log base 2 of 3 times 7 is the same as log base 2 of 3 plus log base 2 of 7. Yes. Log base 2 of 3 is 1.585. And log base 2 of 7 is 2.807. Now all I have to do is add these two together. No. And we should get 4.392. Questions on this so far? Let's look at C, log base 2 of 49. Well, 7, we can use 7 to get to 49, yes? It's going to be what? 7 squared. 7 times 7, 7 squared. And according to our power property, we can move the 2 out front, telling us that we just have 2 times log base 2 of 7. Now, since we know that log base 2 of 7 is 2.807, we replace it with that value. And then we just need to do what? Multiply it by 2. 4 greater than 1, 1. Telling us that it's going to be 5.614. I mean, we could have done, if they gave us 9, 27, 81, any power of 3, we could have done the same thing like we did with this here. Does this make sense? And this is kind of why they did this, especially with these power properties. Power quotient product. If I have to print them, well, those mean that I don't have to print. I can do log base 2 of 7. I don't have to list log base 2 of 49 or any other power of 7 or any other power of 3. Having log base 2 of 3 and log base 2 of 9 is redundant. So it helps me decrease how many of these logs I actually have to print in space we have to use up. Makes things a little bit nicer. But even nicer still is that the calculator, the graphing calculator, will do all of these for us. And we'll find ways to actually type these into the 30XS. Because we can use log base for that. We won't get to it today, but we will have something called the change of base. And the reason the change of base is nice is because the 30XS, the yellow calculator, doesn't have a log base 3. It uses common logs, log base 10. So if we can change it from base 3 to base 10, it would make things nicer. And there's a way to do that. But we'll get to that tomorrow. Now looking at this here, log base 3 of 4 fifths is going to be the same as log base 3 of 4 minus log base 3 of 5. .456 or 465. Not today. Zero. So we replace log base 3 of 4 with 1.262. And we replace log base 3 of 5 with 1.465. And we subtract those, we get negative 0.203. Questions on A? B, log base 3 of 20. Well, we can rewrite 20 as what? 4 times 5. And since we have 2 terms being multiplied together inside the log, we can rewrite it as 2 logs being added. And as it told us, log base 3 of 4 is 1.262. And log base 3 of 5 is 1.465. And if we add those together, 7, carry the 1, 4, 5, 6, 7, we get 2.727. Last one we're going to look at today is this C here, log base 3 of 25. Well, we can rewrite 25 as what? 5 to the second power. And as we did with the other one, we can move that exponent out front according to our power property, telling us that we have 2 times log base 3 of 5. Now, they already told us what log base 3 of 5 is. Log base 3 of 5 is 1.465. If we multiply that by 2, 3, carry the 1, we get 2.930. Questions on any of this here? We will finish this on Tuesday.